All right, good afternoon, geometry. Periods 3 and 4. Hey, I want to introduce you to the law of sines, part of your next section in your textbook. And what I've got here on GeoGebra, I drew up a triangle with the 30, 50, 100 degree angles. I'm going to show you the length of the sides, and then we're going to use the law of sines to actually calculate this on the whiteboard. So here we go. So what you'll notice here, there's your triangle. It has a 30, 50, and a 100 degree angle, and the length of the longest side is 10, and the short side, notice it is opposite the smallest angle, 30 degrees, is 5.08, and then of course the next leg of that triangle opposite the 50 degree angle is 7.78. And now we're going to use the law of sines. We're going to introduce you, and we're going to show you how to actually calculate those lengths. So here we go, to the board. Oh yeah, look at all these enthusiastic students. Yay. All right, so here we go. The law of sines says that if you have a triangle, and notice, does not have to be a right triangle, and we label it such that angle A, notice that angle A, angle B, angle C, and then notice that the side B is opposite angle B, and side A is opposite angle A, and side C is opposite angle C. The law of sines says that I can make a proportion out of this. I can take the length of A over the sine of angle A is equal to the length of B over the sine of angle B is equal to the length of C over the sine of angle C. So what does this really look like? Well, here's the example. Now, as I showed on the GeoGebra, here's the picture on the board. So now let's fill the pieces into the law of sines. Now, do you have to do all three pieces at once? No, and I'll show we can break that up into just two of them. So the law of sines would state that 10 over the sine of 100 would equal the length of B over the sine of 50 would equal to A, the length of A, over the sine of 30. So that's what that would look like. Now, let's plug some numbers in. 10 over the sine of a 100 degree angle is 0.9848. The sine of a 50 degree angle is 0.7660. And of course, the sine of a 30 degree angle is a half. I threw extra zeros in there just because. So I can break this up. If I want to find A, I can say that the two pieces that I do know, notice that you have to have a complete pairing. You've got to have a side and its opposite angles. So you kind of have to know something before you start this. So choose wisely. So 10 over 0.98 is equal to A over 0.5. So you did a little algebra and 5 times 10, or 0.5 times 10 divided by 0.9848, and A comes out to be 5.077, or 5.078, as it showed in GeoGebra. And then to find B, I take the 10 over 0.9848. Notice those are the two components that I have. And I'm going to say that that 10 over 0.9848 is equal to B, the length of B, over 0.7660, because that was the sine of 50. All right, so you do a little algebra on that one. 0.7660 times 10 divided by 0.9848. That decimal is a little high. And you will find that B is equal to 7.778. Anyway, that is the use of the law of sines, okay? And we will practice that some more, but that's basically what it comes down to. That's an example. Those are the numbers plugged in to find both A and B. And then here's to find A, and there's to find B. All right.